Hey guys, my name is Brayden. Today I'll be taking apart this toaster, looking for potential design flaws, and trying to improve on them.
The way to disassemble the toaster is through the bottom base. There you will find 6 fasteners, 4 at the corners, 2 in the middle. One interesting feature was that it was fastened via 4 Phillips head screws and 2 Torx, possibly a design flaw or just a lack of parts. Once you remove the plastic toggle, you are then able to fit the outside aluminum housing over what I am calling a spring rail system and remove the outside shell. From there, it is pretty straightforward. Everything is mounted to the bottom base, so it all comes apart pretty easily. You have the power supply, timing circuit, and lastly, the heating element housing. An interesting feature is that the power supply and the timing circuit are on opposite sides of each other, so that the main and the ground wire must be ran underneath the heating element. I began focusing my time on the spring cart rail system. This caught my eye due to the large amounts of debris that was found there. This was important to me because, from my experience, the spring mechanism tends to fail and no longer latches as designed, and the debris may be part of the problem. One of my main design improvements would be to create some type of housing that protects the spring rail and timing system from any outside debris. When you push down the handle, the plastic bar presses against the contacts and supplies power to the circuit board. The simple circuit made of transistors, resistors, and capacitors turns on and supplies power to the electromagnet. The electromagnet attracts a piece of metal in the handle holding the bread in the toaster. The simple circuit acts as a timer, a capacitor charges through a resistor, and when it reaches a certain voltage, it cuts the power to the electromagnet. Through SolidWorks, I've come up with a simple housing piece that would slide over this exposed area and not allow any outside material to get in, but also not affect the system's current function. My second design improvement would be to make all the fasteners the same. We talked about this a few weeks ago in lecture that when designing a product, try to A. Limit the overall number of fasteners, and B. Limit the varying types of fasteners. From the disassembly alone, there are 4 different types of fasteners to use, all of which serve the same purpose, and that is to hold the objects to the base. I think a universal fastener would achieve the same job. Also, when looking at the outside housing, you have this aluminum shell that's reinforced with a plastic frame. Holding the frame to the housing, it uses 18 fasteners for 3 varying types. Overall, this system has way too much variability and needs to be addressed. Overall, hope you all learned something today. Thanks for watching.